it on?
It's on. Yeah, I can see your whole face. Go
Mine?
sit.
Wait,
Go.
can you see me?
No, go sit. Go. I don't want to
I
go.
think it's It's
Okay, alright, here we go.
Hey,
First thing you
are
need. You need a piece of paper, tear out of your notebook, put your name and date on it. No, it is not a pop quiz, calm your jets. So, name on it, date on it.
I think I got your chair. My jets are speaking up. Well, this one is the 4th through November.
Okay, alright. And it's pretty quiet here, we gotta go through this pretty quick.
Oh, yeah.
Lord, I don't even have a paper out.
Put it in a bun.
What's the date?
I'll pre-order it tomorrow morning. Well,
Pre-order?
I think pre-order start at 7 o'clock tomorrow.
Don't do pre-calc. If they're watching this or
Who's won it?
sorry, you're pre-calc. Hey, what's up, you guys?
I don't know what's
Hey, it's your boys.
This is the 13th.
Hey, it's your boy.
It's 12.
Hey, we'll be back with another vlog.
Things look important.
I should watch this for entertainment. Probably just stare at the
Okay, here's what I'd like you to do. You got a piece of paper out, you got your name on it, put the date on it. I got 5 problems on the board.
Are these graded?
No, so calm your jets, not a quiz. Alright, so here's what I want you to do. I want you to take 5 minutes, and let's see what you can remember about factoring. If you don't remember too much, fine. Try your best you can. I got 5 problems on the board, they're all different types. Put them on your paper and try to factor each one as far as you can, if it's possible. So factoring is when you break it up into multiple parentheses, or you take out things they share. So you're going to try to factor these problems apart. Okay? Do the best you can. In 5 minutes, I collect it. It's not great, it's not a quiz, nothing. I just want to see where you're at now versus when we're done.
Wait, like graded one in factor?
What?
Second?
Guys, he doesn't want to edit this.
Yeah, now if it's not possible to factor it, so be it, just move on to the next one. Sometimes happens.
Oh, 2
Three X.
So you just want us to do that?
And then I just have X.
Divide by 3.
Nope.
Have your right around? Go with, you're good. Go with what you just said. It's not a quiz, I just want to see where we're at currently. And then after we're done with this, I want to see where we're at when we finish, see if we got better.
You're gonna be disappointed.
I hope that you get better quickly.
Don't do it.
I'm taking most of the time to start.
This gives me anxiety.
So I'm giving you 5 minutes.
5 minutes, it's been like.
Okay, now remember, we have homework due today, that's page 53. Everything in the grade book is up to date, unless you just turn in 53 now. Those will be hopefully in the grade book. I'll hand these back now. Late work, missing work, fixes, because I know some of you are like doing that right now. All late work, fixes, corrections, those are due by next Friday. That is the last day of the midterm. So keep that in mind. All fixes, corrections are due by next Friday. I think we have a, I think one of the assignments we've done previously, I think it was like a page, was it page 30, that like the 0 date's coming up to Monday. So like you can't do it after Monday, so if you haven't turned that one in yet. So double check, it's your responsibility to go and check those grades. So, page 28's 0 date is literally tomorrow, or is Monday. So, if you have not turned that one in, that's your responsibility to get that one done.
These are hard.
Kevin Myers.
Can't simplify it. That's what I said. But Mr. Ward said, Cardinal Pride.
Is that what you're supposed to do?
Adam, your school papers, if you want to make sense, you can do it by next week. We're gone the other day.
He's gonna write it down. This is stressing you.
This is hard.
Excuse.
28 and 5.
Okay, I'm gonna collect in about 2 minutes.
You might as well take them now.
Mine right.
Question mark. I got the first one.
I just wrote down.
I got the first 5, but I don't know if they're right.
Can't.
We want to put these in the same spot.
Let me give you that. Okay, if you are finished, I'll take it. Because I know some people are.
I don't know what I'm doing.
I might as well waste time.
Did you just write them down?
I did the first one, I wrote down the second one.
What's your number?
I wrote down all the problems and then I did.
6 and
I literally wrote it down.
Oh.
Didn't we have like a 6-week long thing?
Brody,
I literally just wrote down.
I don't know. I can't do it.
Bernie, it's 6 and 1.
That's all I have.
Oh, yeah.
What did you do for
I didn't even do that one right.
I entered number 3. You can't take out 4
I literally
and 5.
A 3
You need to
and
there when you can always leave it in here.
First one totally good.
it's always here.
No, because it's for
Less than a minute. You got like 45 seconds.
I'm cranking them out now.
Again, this is just the first. I just want to kind of see where we're at. No matter if you get it 100%, no matter if you get it wrong. I just want to see where we're
in
at.
these two.
30 seconds.
I think I got numbers.
Where do you foil these?
This ain't fair.
Yeah.
Right, it's 2x plus 5.
2x plus 1 x plus 2.
Why not?
Stupid.
You have to find the.
No, you got square it.
Maybe.
I don't think you have.
The little thingy.
Okay, I'm gonna walk around. I'm gonna collect it from everyone. Tear it out. Put your name on it for the date. I don't care if you're done or not. I'm taking it.
Are they so?
All right, bye.
Whoa, come on. I'm on one. No, I want to write down. Just ain't fair.
He's gonna look at
Hey,
that.
can I write 2x plus 5 for 1, please? Thank you.
What?
For number 4.
What?
Can I add a 5 and then it's done?
It is now.
Go make them. I'll do it.
Hey, does everyone have it?
Yeah.
I will do it.
All right. Okay, everyone's got them turned in?
See.
Okay, all right. Here's what you need to have. Okay. I want to see kind of where we're at before we even start. Yeah, these are difficult. These were homework problems that eventually we will probably have. I just pulled them out of the textbook. I want to see kind of where we're sitting right now before we even go into the section. This is one of the last sections we cover before our next test or test in here over this chapter P, or first chapter, is next Thursday. So this is like one of the last sections. We're going to start doing it today. We'll do it tomorrow. We'll do it Monday. And then we'll kind of see review days, Tuesday, Wednesday next week, kind of a thing. That's tentative dating, and then test is next Thursday. That's what I'm looking at right now. And I just want to make sure, like, where are we sitting right now on this stuff? Like, obviously I can tell, like, some people need practice on it, because that's, I kind of figured it. This is stuff that a lot of people don't remember. It's just like weird, quirky rules. That's what I want to go over, okay? We'll come back to this. We're going to go over those answers, not right now, at a later time, because I want to see what we can do on our own. I don't want to just give you the answer, because that just kind of gives it away. So, let's walk through the stuff today. So, I recommend that you have your notes out. We're going to do just a select few problems. I think I have 4 problems picked up that I want to do today. That's it. Like, it's pretty short and sweet. It's just that I want to make sure that you guys get these in your notes so you can refer back to them, because obviously it was very clear some of you need to take notes on this stuff, like you don't know it yet. So, here's what we're talking about. We are going to discuss, we need to discuss the different types of factoring. Okay, so we need to talk about the different types, the different classifications, if you will, for factoring. There's 5 types. We're not going to cover all 5 today. We're not. We're going to kind of intro them today. Today is an intro day. Okay, so number 1. Number 1 is called a common factor. We'll talk about that here in a second. That is the first type. This type you should always attempt first when you look at a problem. It's the first go-to type. We'll go through an example of it here in a second. Number 2, the second type is called a trinomial. There is 3 types of trinomial problems. 3 types. That's what most people forget. There's 3 types. We're going to go through some of those today, if we can get a chance to. Now, if we have extra time, this is kind of where I'm sitting. I want to see if we can get to difference of squares and do at least an example of it. If I can get to that. Difference of squares. Okay. So difference of squares is just what it looks like. Pretty straightforward when you start comparing them to the other types. Number 4 is the cube rule. Cube rule. And then the last type, which we are most definitely not covering today, because I know just timing-wise we won't get to it. The 5th type is called grouping. It is one of the most difficult types to try to show, because it changes per problem that you're on.
I don't think we learned that last year.
Okay. So these are my 4 or 5 general types. Obviously, my goal is to show you kind of like an example of each type. That's what I want to talk about, except for the last one. I just know timing-wise we won't get to it today. Okay. Now, some of these might mean something to you, some of them won't, because obviously you remember certain things. Once I start showing you, like, oh yeah, I remember what we did there. So, first type, just kind of making up a problem.
Or make a G.
What?
Draw a G.
No. Alright.
Don't make fun of him.
You see how I did that?
You already told us.
That was whack, yo.
I know.
Okay, so, alright, so the first one. This is a common factor problem. Because when I start a problem and I first look at it, I notice that they all have something in common, right? This one, they all have an X in common. They at least have something. Maybe your problem doesn't have anything in common. Then you move on to a different type. But for right now, when I see it, yeah, these all have X's. Now, what's the minimum number that they all have? They all have at least 1. That's what you have to take out. You have to take out the bare minimum that they all have at least. So in this case, I'm taking out at least 1 X from everything. Now when you do that, the items that are left in this parenthesis are going to be the same number of items that we originally started with. Well, the item that I started with was a trinomial. There was literally 3 things written on the board. An x squared, a 10x, and a 15x cubed. There should be 3 items in here because they have to stay there when you do common factors. Now what I'm going to do is I'm just going to take an x from each of them. So x squared, that turns out to be an x. 10x just becomes a negative 10, because I just took the x off of it. And the 15x cubed becomes a 15x squared. Straightforward, that's it. That's common factor. Now, if you can, you would look at the problem and see if you can go further. I'm not going to do that. Do we understand what common factors mean?
Yep.
Now, the difference is, if you had a number as well, because maybe your problem had a 5 here.
Then you take 5.
Then you take a 5 and an x out, because maybe they share numbers and letters. So in my case, I'd have to take a 5 and an x out, so this would now become a 5x outside. When I took a 5 from here, you divide a 5 out, so that's a 1x. Divide a 5 out, this is now a negative 2, because I divided the 5 off of it. Divide a 5 off of this, it's now a 3x squared. Because you're taking a 5 from each. You're dividing it literally out of the parentheses. How you know that you did it right? If you want to double check, you can literally just multiply the 5x back through and come up with the original problem you did. That's how you can double check to see if you did it right. Okay, does that make sense what common factors are?
Yeah.
Most people just need to see it one more time, how you're taking an X or an item. You can have multiple letters you're taking from each, but you have to do it from every single item. Okay? Alright, are we good so far?
This is like the first problem on the little sheet.
Yeah, yeah. Same problem.
Yeah, we didn't have any other ones of these on the sheet. It's something called showering.
They're like little straight.
Have you
Okay.
tried that?
Hey, let's go to the next type. Next type. Trinomial rule. Now, I warned you, there is 3 types of trinomials. There is 3 types. I'm going to give you the first type. Here we go. Okay, here's the first type of trinomial. What I mean by type, because some people learn this, some people don't. When I look at a trinomial, it's obviously got to be 3 items. I put it in descending order. You can rearrange if you need to. But what I look for is I'm going to try to see if there's anything in common. There's not. There's nothing. There's not like X's in everything or a 2 in everything. I'm going to go on to my step for trinomials. Trinomials require that you break it up into 2 parentheses. That's what you're attempting. It may not work, but you're attempting to do this. Now, in each parenthesis, there is going to be a binomial in each. Okay, so we're taking a trinomial and making it into 2 binomials. That's what we're doing. Now, here's the rule that I've learned that I try to show. Some people learn it, some people don't in terms of like previous years. It just depends on who your instructor was. So, here's the idea. When I look at this problem, the first thing you look at is you look at the symbol in the back. The back symbol. That tells me everything about this trinomial.
It's negative.
The back symbol is what?
Positive.
It's a plus. Okay, so what that plus tells me, if it's a plus in the back, that means the operations that you're going to put in here, because obviously there's going to have to be an operation, because it's a binomial, so there's got to be something between the two numbers. What a plus sign in the back tells me is that these operations in here are going to be the same. That's what a plus sign means. It's automatic. They're the same in both parentheses. Now, what they are requires that you have to look here. This is what they are. They're the symbol in the front. So, in my case, they're both plus signs.
Oh.
So, if this problem had a negative here, they'd be both negatives. They're the same, they're both negatives. Okay, does that make sense?
Yep.
Now, how you break up the items now, how you actually put numbers and terms in each parenthesis. The first item in these parentheses are made from this broken up. The first item broken up. If it's something easy as x squared, break it up evenly, x and x. If there was a number out front, now you have problems where you have to like break it up into different factors. If that was like a bigger number, like 12 or 20, you might have a lot of different options you could put. 1 and 20, 2 and 10, 4 and 5, you know, you have options. But for my case, it's very easy. It's x and x. Easiest thing in the world. I don't even have to think about it. That's the first item. The item in the back of these parentheses. The item in the back. They're made from this 3 broken up into factors of 3. Well, 3 is an easy number. It's prime, right? So what are the only two numbers that give you 3?
3 and 3.
3 and 1.
3 and 3.
3 and 1. And what you want to make sure of, if you know you did it right, FOIL it together, like multiply that out in your head, and see, does this thing give you, if I were to multiply that out again, would it give me the original prime I started with? Yeah, it would, because these are going to multiply out to be x squared, 1x, 3x, that makes the 4x's in the middle, and then this would make a 3 in the back. That's it. That's your answer. The 4 is made from the 3 and the 1 because they're adding. Now, this is the part that some people are never taught. And this is the question I just got. How do you know you're getting the 4? Do you agree that both symbols in both parentheses are the same?
Yep.
These two numbers have to add to make that number. Because they're the same. They're literally the same digit. They're going to add to make the 4. The only difference this would happen is that there's a number out front, and now it's a total guessing game. Okay, are we good so far? Yeah. Let's do another one. Second problem. X squared minus 7x. Let's go with plus 18.
Is this another example?
No, no, not that. Let's go with
minus 2.
let's go with 10.
This is
Let's go with 10. 10, sorry. Yeah, another triangle. Okay, so same exact idea. Same exact idea. Now, here's the idea. On this particular problem, there's no common factor, so I'm going on the trinomial. You're going to break it up. Yeah, just all right, so let's go ahead and notice that.
Make sure that stays in.
All right.
Edit it out. She's gonna watch it. I'm watching this tomorrow.
All right. Hey, so what I have there in the back is I have a plus sign. So, I have a plus sign on the back, so that means the operations in both parentheses are going to be the same, and they're both going to be negative signs. So, negative, negative. Now,
What is this example of?
so here's the idea. The next part,
X minus 5, X minus 2.
Good, bro.
I'm going to break up the x to be x and x.
No, keep them open. Just start. Maybe it'll cool down here. Shut the door. Hey, can we go swimming after school? Shut the door.
I mean, if you want to, Brody.
Little window. We got a nice lake outside.
Go on back.
All right. Next. Okay, so next, what we have to do here. We broke up the x and x. Now we have to break up the 10. Well, obviously 10 has more than just one set of factors. Like 3 was easy. It was 3 and 1 no matter what. You could switch the numbers around, you still get 3 and 1. But 10, you have 1 and 10, 10 and 1, 2 and 5, 5 and 2. In this case, how you know where to put them, you have to make sure that you're getting numbers that multiply give you 10. Those are easy. But they have to add to make the 7. Why they're adding, they're both the same symbol. So they're adding to make 7. So in my case, I'm going to have to put a 5 and 2 or a 2 and 5. No matter what, they're going to give me a 7 in the middle. It doesn't matter where they go because you're adding them anyway. Does that make sense for the numbers I'm picking?
Yeah.
Yes,
Sir.
Okay, now, those were the 2 types of trinomials I hinted at. There is a third type, and the third type is any time they put a minus sign in the back. It doesn't matter the type of problem, as long as there's a minus sign in the back. So here's the idea. Let's say we're going 3x squared plus 2x minus 4. Let's say that that's my problem. Well, this is still a trinomial, but the problem is that when we separate these out into 2 parentheses.
You have to go like.
You can hit it hard.
Stop. It's annoying me right now. So, we have to separate into 2 parentheses, and now the minus sign in the back is telling me that they're automatically opposites. Because the plus means they're the same operation in both. If it's a minus sign in the back, I don't need to look at anything else. It's automatically plus minus or minus plus, I don't care which one you pick. But they're automatically opposites. Does that make sense what the back symbol means?
Yeah.
Plus means they're the same, negative means they're opposites. So that's my little rule for trinomials. Most people don't know that, they just don't think of that rule. So now that we know that, now what we have to do is we have to break this up. The part that makes this difficult, the number out front and the 4 in the back affect the number in the middle. It's not just like on that 10 over there where I did 5 and 2. This one, to make the 2 in the middle, I have to use a combination of 3 and 4 and the factors of them. That's the hard part. Now, the 3 is an easy number. I picked it on purpose. The only way you can do 3 is if you go 3x and 1x. You can switch the 1 and 3, but those are the only options you have. When you go to the back number, I have options. I have 1 and 4, 2 and 2, so I have options. I always say stick with the easy one. Go 2 and 2 first. And see if it's going to give you the right number. So you double check. So I broke up the 4, I broke up the 3, and to double check if this is going to give me the positive 2 in the middle, just FOIL this out in your head and see if it works. If it doesn't, maybe we'll have to switch numbers or switch the signs. I'll show you what you need to do. In this case, 3x times 1x is 3x squared. 3x times a negative 2 is a negative 6x. 2 times 1x is positive 2x. And 2 times a negative 2 is negative 4. Well, when I add these together, I get a negative, what is that, negative 4?
Yeah.
Doesn't work, right? So, in this case, maybe I need to switch the signs around. Well, is this number the exact same number as this? Not even. If it was like a 4, I would just switch the signs and I'm done. Because my answer came out to be negative. This might have been positive 4. I just have to switch the signs. If I was off by a negative sign. But I'm not. It's a different number. So maybe I got to switch the 1 and 3 around. It won't work because it's the same digits, 2 and 2. So now what we're going to need to do is try to move these around and go like 4 and 1 or 1 and 4. So do you see, like, it's literally trial and error. I don't have a shortcut for doing a trinomial like this where you have to try different combinations to make the 2. In fact, here's the bad news. On this problem I made up, I can't factor it. Because at no point can I make a 2 in the middle with a 3 and the 4 in the back. Because the most I'll make is I can make 12 minus 1, which is like 11. Because I can put the 4 back here and the 1 here. So I can make numbers like that. I can't make a 2. So this problem is non-factorable. Because the numbers I'm picking can't make the 2. You can have that. You might have had one on those 5 problems you had, maybe. Okay, is there any questions with if you have one that you can't factor apart?
So that's the third time?
That's the third time, right? Where you try different numbers and combinations. Okay, are we good so far? I only got 2 problems left and we're done. 2. These are very straightforward if you walk. I'm going to go through the difference of squares first, one example of them. This is the easiest rule we have. And the cube rule kind of goes off of it. It's the same style. Okay, so difference of squares. So here we go. of squares, I'm going to put an example up here. Okay, here's what we have. For difference of squares, this is the easiest rule in the world. Do you have a difference of two items that are perfect squares? So when you look at that problem, is there a difference in between them?
No.
Difference means subtraction, right? So is there a minus sign between them? Yeah. Are they perfect squares? Yeah. Variables just have to have even powers. That's easy. So if it's like 2, 4, 6, or 8, or 10, whatever the power is, as long as they're even, that's a perfect square. And then the numbers, we know it's perfect squares. 1, 4, 9, 16, 25, 36. Like if it's one of those numbers. So for difference of squares, this is literally a trinomial rule. Even though it's a binomial, to start with, we can still do the trinomial rule to this problem and solve it. The reason why, and I'm going to show you the shortcut here in a second, because I can literally write this problem like this, and it's still a trinomial rule. It is literally 3 items there if I throw the 0 back in there, and that's in descending order. So the trinomial rule is, what's the rule if there's a minus sign in the back?
The opposite.
It's opposites, right? Plus minus. So you're going to have 2 parentheses that have plus minus. That's actually why they teach you that rule in Algebra 2. When you have a difference of squares, it's automatically plus minus because of the trinomial rule. Now, I'll ignore this. I just showed you why it's going to be a plus minus. That's the only reason. So just ignore that. Okay, so up here, all you have to do is break up the x squared evenly. How do you break up x squared?
X.
X and x. Easy enough. For the 25, you just take the square root. 5 and 5. Done. There's your answer. It's the easiest rule in the world. It doesn't matter what they are as long as they're perfect squares, it will work. So if I had like, let's say I had an 81 here. Well, 81, x squared, that is a perfect square. Yeah, it's just a 9x, 9x. You just take the square root of those numbers. Or letters, whatever they are. Does that make sense how you do those problems?
Yeah.
Easiest thing. Now, cube rule. This is my last problem of the day. Last problem. Cube rule. Let's go with 8 plus x cubed. Say that's my problem.
2.
Okay, so cube rule is different. It's not a difference of squares. Difference of squares has to be a binomial. It has to be a minus sign. There has to be perfect squares here. On a trinomial, they have to be cube numbers. Cube numbers are 1, 8, 27, 64, 125, 216. Those are the cube numbers. And then the variables have to be multiples of 3s. Okay, those are cubic numbers. So we're going to do the cube list. So here's the rule. For cube, it's going to be a small parenthesis, large parenthesis. That's how you do the cube rule every single time. If this is a binomial here, right? That's a binomial, and this is a trinomial. That's the basic rule that you have to follow. Now, you'll probably see this, and I'll give you a little acronym here in a minute that will help you out. For this rule, it kind of looks like you're doing difference of squares. It's just a little bit different. Just a hair. This trinomial really throws people off. Okay, what we need to do is get the first parenthesis done. If we can get this parenthesis, that will give us all the answers for the back. The first parenthesis is the important one. Okay, so here's how it works. In the first parenthesis, this symbol is going to go right in here. It automatically gets copied. So if it's a plus or a minus sign, it will go in that first parenthesis for a cube rule. Cube rule works on both, because it doesn't say a difference of cubes or a sum of cubes. It can be anything plus or minus. So we did it. We moved that plus sign to the front. Now, what you have to do to get these numbers that go in here, you take the cube root of these numbers. What number multiplies on itself 3 times giving me 8?
2.
2, that goes here. Because that 8's in the front, the 2 goes there. What's the number or letter that multiplies on itself 3 times giving me x cubed?
X.
An x. So we put an x in there.
B.
Okay? Does that make sense how I got my 2 things? So
Yeah.
even if this was like a 64, the number that multiplies on itself 3 times giving me 64 is a 4. So I put 4 there.
4.
Okay, now, how you get the back parenthesis. The back symbols are made from this one. It's going to be the opposite symbol going next. The next symbol will be the opposite every single time. The back symbol is always a plus sign. Now, we have an acronym that helps you remember this. It's called SOAP. They use it, they print it in every textbook.
Soapstone.
It means same, opposite, always positive. So same symbol in the front, opposite in the middle, and always positive in the back. It's called SOAP. So follow the SOAP method for doing cube root.
When did we learn that?
Soapstone?
Yeah, they usually have it, it's printed in every math book.
Soapstone's in English.
Ah.
All right, now, okay, to get the numbers in these parentheses, here's what you do. It's made just from these two numbers. It's the easiest thing in the world. In fact, it's actually based on Pascal's triangle. I just don't want to show you
Always
that.
positive.
So, here's how it works. To get this item right here, this first item, you take the front item and square it.
4.
Okay. That's 4. It's 2 squared. It's literally the front number in that first parenthesis squared. The middle term, this middle term, is made from multiplying these two things together.
2x.
2x. And you ignore the signs, because we already have all the signs filled in. So if it's positive or negative, just ignore that. Okay? And then the back number is the back item squared.
Extra.
X squared.
Cool.
It's made from the first parenthesis. Squared, multiplied, squared. Now, I can show you that it's based on Pascal's triangle. I'm not going to do that.
Who's Pascal?
A genius.
All right. Questions on any of these? All right, here's the idea. Hey, before we're done today,
I thought we were done.
we are, but here's what I want. That piece of paper you just turned in, I'm going to hand it back to you. You get 5 minutes to try to do it over. I'm going to give you the problems. I'm going to write them back on the board. I just walked through them. I want to see what fixes you can make from the 5 minutes I spent on each problem. Okay? And I do want you to attempt, so if you need to make fixes, do that. If you feel comfortable with your answer, turn it back in. But I will not accept that, well, I just don't know how to do it. Because I literally just spent 35 minutes teaching you it. So you should learn something up there.
Yeah, guys.
We have 1 minute.
I tried last night, buddy.
Thank you. Oh yeah. I'm grinding them out.
Mine's already done. What'd you put? I already know it.
I didn't get all the questions written down.
So I'll put the problem on the board. So piece of paper, name on, date.
Same thing though.
Here.
Oh, I don't have my name on mine.
Yes.
That might be an issue.
Hey, Ward.
Winner.
It's the,
That's fine. All right. Okay, I'm gonna put the 4 or 5 problems back on the board. I want you to attempt. If you don't get them right, it's fine. It's nothing. We're not grading. This isn't a pop quiz. I just want to see how well you did. And I just tricked you. All right. So here we go.
Greatest common factor. Or common factor.
Okay. Here's the 5 problems. Number 1. 3 squared y minus 12x y to the 5th. Try to factor that apart. X squared plus 12x minus, or sorry, plus 48.
Is there one of each kind?
3, 4, x squared minus 25. 4, 8, x cubed plus 125. And number 5, 2x squared plus 7x plus 3. Okay, there you go. I would like you to attempt to write them on paper. Do the best you can. You have exactly 5 minutes. I want these before you leave. Do not walk out with these. Now we have homework due today. That's on page 53. If you're gone, you have another day to work on it. But 55 is due tomorrow. I think most people will turn in 53 already. But if you haven't, front or back basket before you leave. Okay. Yes.
Okay, so I did it right to here, right?
Okay.
And then I put this in parentheses.
Yes.
And I make it negative.
Yes.
And then I add the other two
Yes.
in a parentheses.
This is 6.
Now the way you explain that is right. Let's see if you write it down correctly.
This can't be done.
Some things can possibly not factor for it.
pulling my leg. Which one do you want, Brady?
One. How do you do number two?
I don't think.
Because you weren't here for the most part.
Yes, I
You
can't
want
figure
it
that one
big.
out. You can't
I don't
get
think you can
48
do it.
top.
You just want it big.
2.